These are the video notes for Chapter 2 test. You're going to need to know how to find the domain and range of a function if you're given a graph or an equation or a function. Okay, looking at number 1, the domain, just look at your x-axis and see if you can trace every number on the x-axis back to the graph. Okay, there isn't one value for x that's not going to be traceable back to the graph. So the domain is all real numbers. The range is along the y-axis, okay? And you can trace all the numbers along the y-axis back to the graph until you get to this section right in here, okay? So those are the numbers that will not be part of the range. Okay, if we look at the graph, how it's numbered, the scale, this is -1 and this is +1. So the range is going to be -infinity, which is down here, up to -1. Actually, there's no union there because it doesn't show. And then from 1 to infinity. Okay, and so on number 1b, you would look at it the same way. Look at your x and y axis. On 1c, since this is a square root function, we know that you cannot have 0 underneath the radical. So -x is going to be equal to, or actually we cannot, it can be equal to 0, I'm sorry. It cannot be less than 0. So if I put in, okay, we do not want it to be less than 0. It can be equal to 0, but we don't want it to be less than 0. Okay, so if I put in, if x is -1, for example, negative times -1 is +1, and that works out. But if I put in a +1, then we have a -1, and we cannot do that. Okay, so what's going to happen here is on the number line, every number that is greater than 0 is going to provide a negative answer under the radical. So the only numbers we can choose are from 0 to -infinity. Okay, so the domain is going to be from -infinity up to 0. Okay, and since this is a square root function, the graph's going to look like this. Okay, so the range, if we put in some numbers here so we can see what our range is. Okay, starting at 0, square root of 0 is 0, square root of 1 is 1, square root of 2, we'll pick one that's a perfect square, -4, so the square root of 4 is 2. So what's happening on the graph is 0, 0, -1, +1, -2, +2, and so on. So my graph is going like this. So the range is coming in from +infinity, okay, but goes to 0. So the way we're going to write that is the smallest number first, 0 to infinity is going to be the range. On 1D, give the domain only. When you have a rational function, the only problem that you could run into is having 0 in the denominator. So x minus 5 equals 0, x equals 5. The only time you're going to run into that problem is when x is equal to 5. All other values of x work. So from -infinity until we get to +5, Notice I'm going to put parentheses instead of a bracket because I don't want it to be equal to 5. Then we're going to skip over 5 and go from 5 to positive infinity. Okay? All of those numbers will work for the domain. Number 2, find the equation for the circle satisfying the given conditions. My center is HK and the radius R. X minus h squared plus y minus k squared equals r squared. I'm going to fill in the values that they give me for h and k. X minus a negative square root of 2 is going to be x plus the square root of 2. Quantity squared plus y minus the square root of 6, quantity squared, and then whenever I square a square root, it just ends up with no square root symbol, so it's 11. And this would be the equation of the circle. Okay, on number 3, find the center and the radius of this circle. So what we're going to have to do is complete the square. And I'm going to move that minus 12 over before I can do this. Okay, 8 divided by 2 equals 4, and 4 squared equals 16. So I'm going to add 16 to both sides. Okay, negative 12 divided by 2 is negative 6, and negative 6 squared is positive 36. Okay, completing the square. This is my x minus h and y minus k. Okay, that's going to be half of 8 was 4, so x plus 4. Half of negative 12 was negative 6, so x plus 4 squared plus x minus, not x, y minus 6 squared. Okay, and then when we add all three of these numbers, we get 64. So the center is going to be negative 4 because x minus negative 4 gives me x plus 4. So negative 4 comma 6, y minus k, so k is just 6. Okay, and the square root of 64 is 8. So the radius is 8. Okay, use the point 4, negative 3, and 3, 2 to answer all of the following questions. What is the slope? The change in y over the change in x. Okay, so if I take negative 3 minus 2, I get negative 5, and 4 minus 3 is 1, so my slope is negative 5. What is the distance between the 2 points? The distance is the square root of x minus x and y minus y. Okay, so remember, we can just use the work that we've already done. When we found the change in y, we got negative 5. So negative 5 squared. And when we found the change in x, we got 1. So 1 squared. 1 squared is 1. Negative 5 squared is 25. 1 plus 25 is 26. Since the factors of 26 are 2 and 13, we cannot simplify that radical. Both numbers are prime numbers. So the distance is the square root of 26. What are the coordinates of the midpoint of the segment joining the 2 points? Midpoint is going to be the average between the 2 x coordinates, the average between the 2 y coordinates. Four plus 3 divided by 2, and negative 3 plus 2 divided by 2. That's going to be 7/2, comma, negative 1/2. That is the ordered pair that represents the midpoint. Okay, standard form of an equation is ax plus by equals c. No decimals or fractions. What that means is integers only. So I'm going to use the slope that I found in the very first part of this problem. The slope is -5. And I'm going to choose one point that's on the line. I'm going to use 4, -3. And I'm going to write the equation of the line. I'm going to follow this pattern first. So -3 is equal to -5 times 4 plus b. Okay, -3 is equal to -20 plus b. Add 20. So 17 is your y-intercept. Okay, so if it was in slope-intercept form, it would look like y equals -5x plus 17. At standard form, x and y will be on the same side of the equation together. So I'm going to move this back over by adding 5x to both sides. So positive 5x plus y, 1y, equals 17. That's the standard form of that equation. Okay, write the linear function. Okay, that's what I started off with right here. So y equals -5x plus 17. Okay, and we're going to replace the y with f of x to represent it as a function. Okay, find the point-slope form of the equation of the line passing through 0, 8 and perpendicular to 4x plus 6y equals 12. I'm going to solve this for y first so I can figure out what the slope is. 6y equals 12 minus 4x. Divide by 6. We get 2 minus 2/3 x. The slope here is -2/3. And I need a slope that's perpendicular to that. So the slope that's perpendicular is equal to +3/2. Okay, point-slope form, y minus y1 equals m times x minus x1. Okay, that's going to be your slope, and these two is one of the points on the line. Okay, so we're going to start off with y minus 8, because y is equal to 8, equals 3/2 times x minus 0. Okay, that's the point-slope form of the line passing through 0, 8 that is perpendicular to the line given in A. Okay, since these are the same thing, the slope is -2/3. Parallel slope is also going to be -2/3, same slope. So y minus 8 equals -2/3 times x minus 0. Y minus 8 equals -2/3 x. Okay, that is the line that's parallel to 4x plus 6y equals 12 with a y-intercept of 8.